So we're going to kind of have what I'm going to call like a mini unit. We're not going to have a quiz in this unit. We're just going to go straight from like this unit, or the start of this unit, to like a kind of like mini test slash quiz kind of thing. So I know some teachers call those like a quest, kind of thing, like a quest, So, but we'll see, we'll see what is going to. I have to figure out what I'm going to, how many points and stuff will make it work. Anyway, let's move into things here. We already know what parallel means, right? We talked about them before. Okay, we'll give a definition here as well, though, just to have it. So, most people just understand parallel lines to be two lines are parallel if they do not intersect, right? That's kind of like our major understanding of it, and that works. But I want to add in one more little aspect, and the lines are coplanar. Right? Because in geometry, we're not always talking about 2 dimensions. Sometimes we, also think and want to think 3-dimensionally, which is a little bit trickier to do. Okay. The 2 lines are parallel if they do not intersect and the lines are coplanar. Right? So you're working like the coordinate plane, right? Parallel lines is clear. The symbols that we use for parallel lines, and I guess it's really helpful too, like parallel, right? There's like the 2 L's kind of even make like a little parallel lines there, a little set of parallel lines, right? Parallel pair of L's, right? So anyway, the way you describe 2 lines to be parallel is using this symbol right here, okay? A little pair of parallel lines. And so what this means, that's the notation right there, and it means line L is parallel to line M. Whoops, I don't know why I put a parenthesis there. It should be that. Okay. Remember that we can name lines using a single letter, but it's not a specific point on the line that we're using the letter. It's like a cursive letter, L, M, N. Those are like your typical ones you use for whatever reason. All right. But then also, we've seen pictures, right? We can see pictures of parallel lines. So I'll draw kind of 2 pairs of lines here. And again, I'll label them L and M, bless you. But of course, we know that in geometry, we can't always trust our eyes, right? They look parallel, but are they parallel? Well, there's a way to denote it in a diagram too, and it's using arrows. You can either do like this, okay, putting little single arrows like that, okay, or you can do something like this too. Sometimes they'll draw it this way, like a little filled in arrow. Like that. These symbols denote parallel lines. Okay, so now when you see those symbols, I think we talked about it before. When you see those symbols, that means parallel lines. Okay. And of course, if you have more than one set of parallel lines, I guess I'll go ahead and draw that here. If you have more than one set, so let's say we have like this set of parallel lines right here, and then like this set of parallel lines right here. Okay, you'll mark those differently. So for example, these, I'll put a single arrow there to mark those 2 lines as parallel, and then the second set, I'll do double arrows like that. So you can also see which ones match up. It's kind of like, in this case, kind of like, duh, which ones are parallel and stuff like that. But it's helpful just to be sure. Okay? In coordinate geometry, or plane geometry, plane and coordinate geometry. In coordinate geometry, okay, parallel lines have the same what? Slope. Okay. Have the same slope. Okay, so remember y equals mx plus b. Okay, y equals mx plus b, slope-intercept form. Of a line. Okay, the m represents what characteristic, what aspect of our line? It is the slope. And then b is the good y-intercept. Okay, the y-intercept. Okay, this is not the only way to write the equation of a line. Later in math classes, like pre-calculus and calculus, you'll learn another form that's helpful called point-slope form. You might have even seen it in the past and thought like, ugh, that's uncomfortable. I prefer to use slope-intercept form. And I get it, that's fine for now. Slope-intercept form is most useful for us right now. But later on in those classes, especially calculus, you'll want to also become familiar with point-slope form. Okay, but for right now, this is perfect. All right, so just a quick example here. Okay, let's say we have line 1 and line 2. Line 1 has the equation y equals 3x plus 5. Line 2 has the equation 3x minus 3. Okay, and the question is line 1 parallel to line 2? Are they parallel? Would these two lines be parallel? Yes? Why? Yes, the slope for this one's 3, the slope for this one's 3. They have different y-intercepts. So yes, the slopes are the same. And technically we should also say they have different y-intercepts. Because if they were both 3x plus 5, if both of these lines had the equations 3x plus 5, would those lines be parallel? No, right? Because if they're the same slope and the same y-intercept, what's true about those two lines? If they're the same slope and the same y-intercept, they're what? They're the same. So they can't be parallel. They're going to be coinciding, I think is what they're called officially, right? They're the same line. So you need to have different y-intercepts, okay, as well. All right, questions on any of that? Moving on. Okay, next. Ooh, something's like making a mess here on my desk. Okay, anyway, moving on. Perpendicular lines. Also fun. Okay. So, two lines that intersect and form a right angle. Okay, these also have a notation. It's gonna blow your mind here. Ready? Here we go. L, and then we're going to draw two little perpendicular lines. Okay, that's the notation to describe perpendicular lines. You just create like a little, I guess you call them segments because they don't have arrows at the end of them. Okay, this is the symbol that's used though. L is perpendicular to M. Okay. Line L is perpendicular to line M is how you would read that. Okay, so in coordinate geometry, we said parallel lines have the same slope. I'm going to abbreviate here for this second one. So in coordinate geometry, perpendicular lines have, and then how are their slopes related? Yeah, Avery?
I think it's like the y and the x coordinates are switched. So
Basically the right idea, yeah, essentially the right idea. So then if, for example, if we had, So we'll come back to that in a second here. I think I see what you're saying though. So let me just say, so a line y equals negative 2 over 3x plus 5 would be, I'm going to abbreviate perpendicular, would be perpendicular to a line with slope m equals, and then what would you say there, Avery? So if this line has this equation, what would this perpendicular slope to that be?
Negative 3 halves.
Close. Positive.
Oh, positive.
But 3 halves too, yes. So it's not just flipping it, but it's also the opposite. Okay? So in coordinate geometry, perpendicular lines have opposite. That means if one's positive, the other will be negative. If one's negative, the other will be positive. Opposite, comma, reciprocal slopes. Okay, in coordinate geometry, perpendicular lines have opposite reciprocal slopes. So there is, again, negative becomes positive, and 2 over 3 becomes 3 over 2. So that's your slope. Okay? So let's try this here. And again, the question is, so this is for you guys to try, parallel, perpendicular, or is it neither? Okay? So again, that's your question. Identify whether these paired lines I'm going to give you are parallel, perpendicular, or neither. All right, line 1 we'll say is 3x plus y equals 1. And line 2 we'll say is x minus 3y equals negative 1. Okay? So give that a shot. Take a look at those. Okay? Maybe do a little bit of work if you need to. But identify whether those lines are parallel, perpendicular, or neither. Or neither. Okay? Identify whether those lines are parallel, perpendicular, or neither. Think about whether these lines are parallel, perpendicular, or neither, based off of what we've been talking about. Eli, I like what I saw there. What you were doing. It's a good idea. Okay, cool. You can just tell from looking at it. Okay. Good. I like what you're doing there, Aubrey. Give you like 30 more seconds to figure out the mystery. And then I'm going to call on my first person here. Oh, someone I haven't heard from yet. Okay. Okay. Stephen, your number's up here, buddy. So, what do you say? Parallel, perpendicular, or neither?
I said neither.
You said neither. Okay. And what did you use to figure that out, or how did you go about determining it was neither?
Well, I kind of just guessed, but I do remember you said that that if the slope, if it's the same as parallel, but
Okay.
so since it's not the same, it's not
Gotcha.
I just guessed.
Okay, so how did you go about determining what the slope of, for example, this first line was? What did you do?
I didn't do anything. I just guessed.
Aha, so if I may, did you guess that the slope was like 3 here, for example? Okay, so it would be if we were in slope-intercept form. Is this line written in slope-intercept form?
No.
No, right? How do we get an equation of a line in slope-intercept form? What do we need to do, Stephen?
You need to.
Or you can tell me what we need to do to this specific equation. What could we start doing? If you're not sure, that's okay
I'm
too.
not sure.
Okay, that's fine. So think about what is slope-intercept form? Can you tell me what that?
Y equals mx plus b.
Y equals mx plus b. So what do you notice about that? The y is by itself. There's nothing with it.
So
And then
subtract 3x.
there you go. Exactly right. We'll subtract 3x from both sides to get the y by itself. And we get y equals 1 minus 3x. Okay? So now looking at this, what's the slope of this line?
Wait, which line?
The red one. Sorry, this one here. Sorry, I was tapping my
Oh,
finger, but I was just like, sorry.
1.
So careful.
Negative.
Yeah, I know. I have it in a different
Yeah,
order, so I have that. Yeah. So yes, the slope here is -3. Good. Very good. Okay, that's right. And don't worry, Stephen. I saw other people that were making a similar kind of idea to what you were doing there. So you're not the only one here but I appreciate you working through this one with me here. All right. So the slope of this line is -3, and then what do we need to do here?
I'd say
Or where do we start at least, maybe?
I would subtract x.
Great idea. Subtract x from both sides. We're going to have -3y equals -1, take away x. And then
Add 3.
it's -3 times y. So to undo the times, we'd have to divide. So divide everything here by -3, divide everything over here by -3. So those cancel, left with y equals -1 divided by -3 is fractions. 1/3. Okay. What's the number in front of the x right here?
1.
A 1, but it'd be a -1. Divided by a -3 becomes positive 1/3 x. What's the slope of this line?
1/3.
Good. Okay, so are they parallel?
No.
Are they perpendicular?
No. Oh, but yeah.
Yes, good. I know, like there's one more step here, right? Because this is really -3 over 1. So yes, they're opposite, negative, positive, and yes, they're reciprocals. 3 over 1, 1 over 3. So perpendicular. Okay, good. Thank you for working through that with me. I know that can be painful sometimes, maybe all the time. Okay. But there it is. Good job. Okay, we're all learning this here. That's fine. Questions on any of that? That's the way it should be. Okay. Make sure you're in slope-intercept form, right? Or make sure you're in a form where you can pull that slope out. The slope is not always just the number in front of the x. It needs to be in slope-intercept form first before you can read that. Okay, moving on. All right. Two more vocab. Well, actually, no, I got 2 more vocab words and then some relationships we're going to look at. Okay, so oblique. Oblique. Okay, if you take human anatomy or maybe like weightlifting and you learn about some of your muscles and stuff like that, you have muscles that are called your obliques. Okay, but in geometry it's got a slightly different meaning. Oblique lines are coplanar, share the same plane, and intersect at one point. Okay, sometimes these are just called intersecting lines, but also the word oblique applies here too. Okay, and it's like an old school term for it. Okay, so this is like the boring situation where it's just like, hey, look, 2 lines that intersect. No way. Okay, so there it is. Nothing fancy about that. Oblique. There's one other relationship here, and that is skew. Skew lines. Okay, skew lines are 2 lines that do not intersect. Two lines that do not intersect. But Mr. Whitmire, aren't those parallel then if they don't intersect? Well, and are not in the same plane. So you have to now think three-dimensionally. You have to now think three-dimensionally. Okay, so just as an example here, I'm going to draw a cube to kind of help us think three-dimensionally here, so we can kind of think, but it doesn't have to be a cube. I'll try and draw two examples of like how we can maybe see this represented. Okay, like I said, I'll draw our cube or like a rectangular prism. I don't know if this is necessarily going to be a cube or not, but you get the idea. Oh boy, messing up my... Ugh. Okay, well, it's better than nothing. There you go. Okay, so here's an example. Let's say we have a line that kind of starts on that face of the cube. And let's say we have like another line right here. I'll call that one N. Okay. If you were to extend L infinitely, and if you were to extend N infinitely, would they ever intersect? No. But do we really want to call them parallel? Not really, right? Because parallel has that idea also of they're kind of going in the same direction and never intersect, right? L and N, they're never going to intersect, but we really want to call those parallel, right? Because they're not really going the same way, not going the same direction. So we call them skew. Another way you can kind of think about this is, let's say I drew like a plane. And again, using our normal representation of the plane as like a kind of parallelogram or something like that. You know, you could draw like a line here, and again, call this, I don't know, line M, maybe. And then I could just draw like, I don't know, maybe like a line. Oh, I could do this, I guess. I could draw like a line going this way. Okay, I'll call that like L. You see how L, it intersects the plane, right? You see how it's like going behind the plane there. It intersects the plane, but M and L are never going to intersect because they're going through that plane there. Okay, it's kind of like going through the plane. You know, if I don't know if this is a good idea or not, but we'll try it. Like that. Okay, it's kind of going through that plane, but they're never going to intersect. But we want to call them parallel. So they're skewed. Okay. Questions on any of that? Yes.
I have a question on like both oblique and skew.
Sure.
Do oblique lines include perpendicular lines?
Yes, I believe we would consider perpendicular lines to be oblique as well. Yes,
Okay,
by the definition there.
And can skew lines be parallel if they're not on the same plane and they're parallel?
I think that like, yes, that might be possible in that you could like put a plane between those. Like, I think it could be possible. Yes, I could see it happen. Where like, for example, if I drew line L like here, you know what I mean, like this direction. You're saying like kind of horizontal, like M is, but that would be not so they wouldn't be on they both wouldn't be on this plane, but they would be both on some plane. You could like make a plane between them, kind of thing. I see what you're saying.
What about like the cube, where if you drew line N in the same direction as line L?
Like you're saying, like kind of like diagonally up and down like that too.
Yeah.
So that I would say I would still call that skew, I guess. I feel like what I will say is this though, for example, like this one, obviously, right, we wouldn't even want to call these two things parallel, right? They're not intersecting, but we definitely like look at that like, ugh, not parallel, right? So I would say when you see it like on an assessment or something like that, it should be clear these are skew, these are parallel, and you won't have to worry about drawing the distinction between the two, like with like that kind of subtle of a distinction. Now, your question, I'm not sure the full answer to about the parallel and skew stuff, you know, what you're thinking and stuff. So I will take a look and see if I can figure out an answer for that for you. So yeah, we'll go from there. All right, so sorry, I couldn't answer that for you. All right, some relationships now. One other thing we want to talk about, now that we've kind of mentioned parallel lines, perpendicular lines, and stuff like that, some relationships arise in geometry. And this is where we're going to do more with parallel perpendicular tomorrow. We're going to be like using equations, or not tomorrow, but later in this unit, like equations of lines and stuff like that. We're also going to do more with this in this unit as well. So the specific situation where we have two lines crossed by a transversal. Okay, a transversal. So transverse, traverse. A transversal is merely a line that intersects more than one other line in a plane. Okay? So maybe a better way to say that is a line that intersects two or more. Okay? A line that intersects more than one other line in a plane. Okay, so two or more, in other words. And again, that might be better to say two or more. Okay? I'm going to draw these two lines here. Oops, I'm sorry. I'm going to draw these two lines here, not exactly parallel. Later in this unit, we're going to worry about when these two lines are parallel, but for right now, we're just going to draw these two lines. Okay? And since they're not parallel, we know they'll intersect eventually, but anyway. Okay? And so there we go. So this right here would be a transversal line. Okay? Transversal. Okay. And as a result of this transversal kind of crossing here, we create some angles. Okay? In fact, we create like 8 kind of individual angles here, along with, I guess, some like straight angles and things like that too. We create 8 smaller angles. So I'm going to number these. Please number these like I number them, because otherwise you're going to get, you're going to have a difficult time kind of like keeping in step with my angle relationships here. Okay, so please number those just like I have a number. So I kind of go counterclockwise, starting in the right-hand corner, 1, 2, 3, 4, and then counterclockwise in the bottom section, 5, 6, 7, 8. Okay. Also, just some other things, right? These two lines, okay, we have kind of the space between these two lines. So this like little space kind of in between these two lines, you can think of as like the interior, okay, because it's between them. And if between the two lines is the interior, what do you guess we're going to call outside the two lines? Exterior. You got it, right. Mathematicians are not super creative, but at least the naming makes sense. Okay, at least the naming makes sense. Okay, and so there's like 4 angle relationships that I want to name here. Okay, pairs of angles that have a special name. Okay, the first name would be corresponding angles. That's one special angle pair, and you'll need to be familiar. When I say corresponding angles, you should have an idea in your mind about what that means. Okay, not right now, but I mean that's what our goal is to have that. Okay, corresponding. Anyone have any kind of want to help us out a little bit with what the idea of corresponding means? What does it mean for two things to correspond? Yeah, that's it.
I think it's like if I equal the same thing, like 16.
Okay, yeah. I mean, so in fact, corresponding, I mean, when we have these lines to be parallel, they will be equal to each other. They will be equal to each other. In this situation, they're not going to be because these two lines are not necessarily parallel.
Yeah.
So another way I think corresponding is like you match. It's like matching, right? When you correspond with something else, you kind of match to it. And so it's these angles are all the angles that are kind of in matching positions. What do I mean? Angle 1 and what? And angle 1 and angle 5. Exactly right. Angle 1 and angle 5. Okay, and then angle 2 and angle 6. Angle 3 and angle 7. Whoops, and I got ahead of myself with my angle, with my comma there. And then angle 4 matches with what? I wrote my answer out before I said yes. Sorry, I'm just going to have to do this down here. Okay, angle 4 and angle 8. So all of those are corresponding pairs of angles, corresponding angles. 1 and 5, 2 and 6, 3 and 7, 4 and 8. Those are corresponding angles because they're kind of in the same position. 1 and 5 are like both in the upper right, 2 and 6 are both upper left, 3 and 7 bottom left, 4 and 8 bottom right. Corresponding. Okay? Next, we're going to talk about alternate interior angles. alternate interior angles. Okay, Jake, question?
I have a question about the corresponding angles.
Sure.
Is it just for like the position or the value?
The position. We will sometimes like those angles be congruent to more than one other angle, but yes, just position for right now. Yep, good question, good question. All right, alternate interior. What does it mean to alternate? Back and forth, so switch from one side to another or something like that, right? And of course, interior, so that means we're only going to be dealing with these interior angles. So Madison, do you have an idea about a pair of alternate interior angles here?
3 and 5.
Angle 3 and 5. You got it. So the beautiful thing about these names is that like in the name is kind of like what you're looking for. So it's not like a lot of memorization, it's just like kind of, a little bit of figuring it out. Is that the only pair of alternate interior angles that we have? And then angle 4 and angle 6 would be your other pair. And again, they're interior because it's the angles, we only consider the angles between the two lines that are being crossed by the transversal there. Okay? Well, guess what? We have alternate interior. We're also going to have alternate exterior. Okay. We have different volunteers here that want to give us a pair of alternate exterior angles. Go ahead, Dan. 1 and 7. Is that it? Aubrey? 2 and 8. You got it. Angle 2 and angle 8. Okay. Co-interior angles is the next one. Co-interior angles. Okay? Remember co, that prefix means to like share. So what might be an example of co-interior angles here? Avery?
Angle 3 and angle 6.
Angle 3 and angle 6. They share the same side of the transversal, 3 and 6, and they're interior. So yep, angle 3 and angle 6. And what's the other pair? 4 and 5. Okay. Angle 4 and angle 5. Sometimes these are also called same side interior, which is like even more obvious about what they're talking about, right? Same side interior. Alternate, right? What were we alternating in alternate? It was the alternate sides of the transversal. 3 was on the left, 5 was on the right, 4 was on the right, 6 was on the left. Same thing with alternate exterior, right? We're alternating the side of the transversal. Okay? And then co-interior sharing. There's one other one that can come up sometimes, and that's consecutive. But I think we'll hold off on that one for right now. I think we'll talk about it. And not that one's hard, but I think these are the major ones that I want you guys to be worried about. So we'll just talk about these. Okay? So we don't have, eventually, like I said, we'll talk about relationships. Right now we're just worried about you being able to identify. But eventually we'll come up with relationships between corresponding alternate interior, alternate exterior, and co-interior, about like how they relate to one another. Right now we're just focused on being able to identify them accurately. Okay? So, any questions on any of this? All right. Well, that's all for today. So what I'm going to get you guys to do here is get started on your assignment. I'm going to put it up on the Google Classroom right now. So that way you can get started on it. All righty. Let me put that up here. You guys can get your Chromebooks out or your smartphones if you want to use them.